All right, so I was gone a couple days, so I'm going to record bell work even here just to make sure we got it. Solve the equation algebraically. So 3 to the x, 9 to the x minus 1, and 1/3 of the 2x. When we see something like this, okay, the best way to solve it would be to rewrite everything with the same base. Because this thing is multiplied, that's definitely really going to help us out here. What base should I use here? 3. I'm going to rewrite each thing with a base of 3. So it's 3 to the x times 3 squared times the pre-existing exponent. 1/3 I could rewrite as -1. 3 to the -1, so 3 to the -2x. Everybody good to that point? Then we are going to combine. So I want it to just be a base of 3 on both sides. So over here on this side, we're good. 3 to the -2x. What is it going to become? Obviously, if I distribute that, it's going to be 3 to the 2x minus 2. What's my new exponent going to be when I multiply those two bases together? X squared or 3x? 3x, good. It's 3x because remember we're adding our exponents. It's x plus 2x because when I'm multiplying bases, I add the exponents. So it's going to be 3x minus 2. Then it's easy. Cancel, cancel. 3x minus 2 is -2x. Subtract 2x or 3x. Divide by -5. 2/5 is my x. Rewriting that side, each side to be the same base, helpful. That's what we needed to do there. Questions on that set? Next part. We are graphing. So this is just graphing exponentials. We did this last Friday? I think last Friday. 2 to the x minus 2 minus 1. It's an exponential. Show me with your arms. What does an exponential look like? It's this guy right here. Does exponential have a vertical asymptote or horizontal? Horizontal. There's a horizontal asymptote. Show me with your fingers. Where's that horizontal asymptote going to be? This one is going to be at -1 because I got that -1 tagged on the end. So I'm going to go horizontal asymptote here at -1. There's that guy right there. I'm doing sorry. We're graphing an exponential. Okay, so my anchor dot is it 1 above or 1 below? 1 above, so it's right here, but it's not going to be right there. Which direction do I need to move it? Right 2. So I'm going to the right 2 from there. There's my starting dot. Then I'm going to graph. It's an exponential. It's got a base of 2. So my first dot is 1 above. Then my next one's going to be 2 above, 4 above, 8 above, and so on. Oh, man, that was ugly. Let's try that again. There we go. Just like that. Questions on that one? Let's go ahead and do what we tried to do on Wednesday, maybe somewhat unsuccessfully, but this is y equals this. We want to graph the inverse of this thing. There are 2 steps to finding an inverse. What's the first step to finding an inverse? Switch x and y, so it's going to be x is equal to 2 to the y minus 2 minus 1. We were trying to get y by itself, so I did that. Now I'm going to solve. So I flipped x and y, and I'm solving for y, so obviously I'm going to add 1. Then I want to get y by itself. It's 2 to that power. How do I get rid of the 2 to that power? What's the inverse of that, William? Log base 2. On both sides, we are going to take the log base 2. The log base 2, because that is the inverse of 2 to a power. So these two things over here are going to cancel. When I take the log base 2, it's of the whole thing. So putting that in parentheses is important. So it's log base 2 of x plus 1 is equal to y minus 2. And so obviously if I want to finish solving this thing, I'm going to add the 2 to the other side. I get log base 2 of x plus 1 plus 2 is all equal to y. That's what I'm trying to graph. Like, we didn't have to get y by itself, but I'm trying to make sure we know how to find inverses. That's another thing on our quiz. And then from here, we want to graph this log. Okay, so hopefully the one thing you picked up on Thursday or on Wednesday, what kind of asymptote does a log graph have? Vertical. And normally it's going to be at where? It's normally at x equals 0. So normally it would be right down here at 0. Okay, but it's not going to be there. Where is my vertical asymptote going to be instead here? -1, because that +1 inside the parentheses is shifting us to the left 1. So that is shifting our vertical asymptote to the left 1. So it's right here. Normally, when I graph exponentials, my anchor point is 1 above. And when I graph logarithms, my anchor point is 1 to the right of my vertical asymptote. So wherever my vertical asymptote is where I would put my anchor dot. So normally it'd be right there, but it's not going to be right there. What else do I need to do with that dot? Up 2, because this +2 right here is going to move us up 2. That's going to be my new dot. And then think of an exponential. When we graphed our exponential, we went up 1 above the line, and then we went 2 above the line, then 4, then 8, whatever our base was. Well, here I went 1 to the right. As I move up, then I'm going to go 2 to the right, and then 4 to the right, 8 to the right, etc. That right there is going to be what my graph looks like. We could have graphed it by just taking the x's and y's and flipping them, but we graphed it using our logarithm transformation rules. Yes, ma'am?
This is a stupid question, but like, how do you know to like move it like 1 and 2, then like?
Because the base is a 2. Okay, so just like an exponential, we're 1 above when we raise it to the 0 power, and then we're 2 above because we're doubling it, and then 4, and then 8. Same thing here. It's a base of 2, so we're always 1 above, 1 to the right, then 2, and then 4, and then 8. It's whatever that base is, just multiplied through. Good question. Other things here? All right. So today in our lesson, we're really quickly learning 3 concepts. Okay, 2 of them are really easy. One of them is just practicing the graphs that we did on Wednesday if you're unsure. Okay, so it says use logarithms to solve the exponential equation. We're solving. Number 1, e to the x minus 3 is equal to 2. We are solving, so we are trying to get x by itself. What do I need to get rid of first in order to get x by itself? E. I can't get rid of the -2 because it's in my exponent. I have to bring the exponent down before I do anything else. So to get rid of e, what is the inverse of e? Natural log. So we're going to take the natural log of both sides. Okay, natural log and e are going to cancel. So it's x minus 3 is equal to the natural log of 2. Careful with parentheses on natural log or on any log because kids start to make some weird things happen there. I took the natural log of 2, so 2 is inside of parentheses. And then to solve that thing, I'm going to add 3. So x is equal to the natural log of 2 plus 3. That is way different than the natural log of 5. You can't do that. The 3 can't be inside the parentheses. Is there a base on the natural log? Yeah, what is the base on natural log? It's log base e. That's why it's called natural log. Natural log is a log base e. We good here? It's not too hard. This is the exact answer. A lot of times, students think they need to use their calculator all the time. You don't need to use a calculator here. That's our exact value. Okay? That's a better answer than you type it into your calculator because as soon as you type in your calculator, it's rounded. And it doesn't ask about rounding. So that right there is an exact answer. We do that in calculus all the time. Okay? If they want an approximate answer, then I'm going to type into my calculator and just make sure you can do that. We're going natural log of 2. Close your parentheses, plus 3. Hit enter. How many decimals do you think we should go? 3. 3.693 is my answer. So again, both of them are the correct answer. This is the exact value. This is the approximate value because we rounded it. So make sure you understand the difference between the two. Just pay attention to what I ask for. I might ask for either one. Number 2 says 4 times 10 to the 2x minus 7 is all equal to 8. If I wanted to solve this thing, what should I do first? Divide. Okay? Think order of operations. The number 1 mistake students make here is they want to make that 40. You cannot make that 40. That's a completely different problem. All right? Order of operations say we need to do exponents before you multiply. And if you take 4 times 10, all of a sudden you're multiplying before you do exponents. So don't do that. Okay? Instead, just get rid of this 4. We can get rid of that 4 really easily by just dividing it over. So then I got 10 to the 2x minus 7 is equal to 2. I want to get x by itself. What do I need to get rid of next? the 10, what is the opposite of 10 to a power? Log base 10, or even better, just log, because log is a base of 10. And so we can just take the log of both sides. On the left side, log and the 10 to a power are going to cancel. That is going to be equal to the log of 2. Then we're solving. Add 7. And then divide by 2. So x is going to be equal to the log of 2 plus 7 divided by 2. Just make sure you can type that into your calculator. That's the exact answer. Now find the approximate answer. So just making sure that you can type that into your calculator in some capacity. Understanding that when I do this, it is log of 2 plus 7, and then it's all divided by 2. So you could either put that in parentheses or put it in fraction form. I'm just going to hit enter after that and then divide it by 2. My final answer is 3.651. So again, this is the exact answer. This is the approximate answer. Questions on those two? Try 3 and 4 with your neighbor. Go. E to the 2x is equal to 5. If you want to solve that, Sam, what'd you do first?
I have the natural log of 5 is equal to 2x.
Good. Natural log on both sides because that's going to get rid of e. So 2x is equal to natural log of 5. Then what'd you do?
Divided both sides by 2.
Divided by 2. That's the exact value, natural log of 5 divided by 2. If I want the approximate answer, I just type it in. Natural log of 5 divided by 2. Hit enter. 0.805. Yeah, that's a 5. Number 4 says 8 times 10 to the 2x minus 7 is equal to 3 if I want to solve that. Caroline Cook, what'd you do first? Divide by 8. Get rid of that 8. We don't want to be multiplied by it. We want to get rid of it. So we move that over. Now I've got 10 to the 2x minus 7 equals 3/8. Caroline, what'd you do next? The log of both sides. Good. It's base of 10. And so to cancel it out, she is taking the log of both sides, which would be the opposite of 10 to a power. That goes away. So 2x minus 7 is equal to the log of 3/8. That's weird, but who cares? And then I would add 7 and divide by 2. That's what x is. That's my answer. Just a matter of typing that in. So again, in my calculator, log 3/8 plus 7 divided by 2. 3.287. Questions there? Yes, sir.
Do we have to add the exact answer?
It just depends on what I ask for. I could ask for either one. I could ask for the exact or the approximate. Just understand the difference between the two. All right. Let's graph some inverses. Again, we did this already. We should be really good at this. I'm going to go pretty quick. Y equals 2 to the x. It's an exponential function. Where's the asymptote line going to be? Show me the arm. What's the asymptote line going to look like? Horizontal, because it's an exponential. So this is my horizontal asymptote. Is my anchor dot going to be one above or one below? One above. It is 2 to the x. So my first dot's one above. My next dot's going to be 2, and then 4, and then 8. And there's my exponential graph, if I could draw straighter lines. It's worse. Whatever. All right. There's that. Then we're going to graph its inverse. So if I graphed its inverse, it'd be y is equal to 2 to the x. And I'm graphing the inverse. Jared, what's my first step to graphing an inverse? Switch the x and the y. So x is equal to 2 to the y power. Then psi, I want to get y by itself. How do I get rid of the 2? Log base 2 of both sides. Good. Log base 2 of x is equal to, when I take the log base 2 up here, it's going to cancel. So it's going to be log base 2 of x is equal to y. So that's what I'm graphing. Okay. We've done this enough now. We should know the basic shape of a log graph. Log graphs have a vertical asymptote. This one's going to be at 0. So I can go ahead and draw my vertical asymptote at 0. It's not been shifted up and down. It's not been shifted left and right. And so my first dot is going to be, where's my anchor dot going to be? 1, 0, 1 to the right. It's 1 away from my vertical asymptote. And then as I move up, how many is my next one going to be away? Over 2, and then over 4. Because the base is 2, I'm doubling each time. I was 1 away, then 2 away, then 4, then 8, and so on. Here is my logarithmic graph. What is the domain of that logarithmic graph? X is greater than 0. Greater than or equal to? Just greater than. Okay? Because you can't take the log of 0. You cannot take the log of a negative number. Okay? What we remember from Friday or from Monday, we talked about that argument has to be a positive number. Or in other words, it has to be greater than 0. All right? So we can find the domain of a logarithmic function without graphing it. If I wanted to find the domain of this thing right here, log base 2 of x plus 3, we could do that by doing this very simple step. It's taking the argument, taking this x plus 3, and saying the argument has to be positive. Or in other words, x plus 3 has to be greater than 0. If I wanted to solve that, I just move the 3 over. Boom, that's my domain. X is greater than negative 3. Because what does this plus 3 right here in the parentheses, what is that plus 3 doing to my graph? Shifting it left 3. So here, think about what that graph looks like. I shifted to the left 3. 1, 2, 3. What's going to happen right there at negative 3? Vertical asymptote, and then my graph is going to look like that. Okay, we could graph it if we wanted to. Alpha F2, log base, what was it, 2? Log base 2 of x plus 3, zoom 6. Yeah, there's my graph. It's starting there. It looks like it doesn't graph it there. It does. But negative 3 is where it's cut off. That's my domain. That is the domain of this thing. X is greater than negative 3. Okay, we can find the domain of any logarithmic function. It's easy. To find the domain of a logarithmic function, you take the argument and you make it greater than 0. So far today, I've let students work on this next one by themselves, and I don't know if anyone has gotten it even close to right. I want to know when that is greater than 0. 1 plus x over 1 minus x, when the argument is greater than 0. We've done this. How do we determine whether that rational function is greater than 0 or not? That's not going to necessarily do it. We're not just taking the denominator and solving it that way, because something else could happen. We can do a sign chart here.
You would know that.
We just tested over it, like literally a week ago. What numbers? Tell your name. Go from there. Make your sign chart. Put the numbers on there and determine the answer to that thing. When is that thing greater than 0? Show me with your fingers. What 2 numbers did you put on your sign chart? On your sign chart, you should have put in 1 and negative 1. Negative 1 is an x-intercept because you would take the top and set it equal to 0. 1 is a vertical asymptote because you take the bottom and set it equal to 0. Okay, the reason it matters is because if you are a fraction and you put a negative over a negative, that would be positive. Or if you put a positive over a negative, that's negative, and you got to be able to see. So then from here, we're just plugging in. What's a good number to plug in? 0. If I plugged in 0 here on top, it would be 1. If I plugged in 0 there on bottom, it'd be 1. 1 over 1 would be a positive number. So 0 would be positive. So in between there, it's positive. A number bigger than 1, like 2, it'd be 3 over negative 1. Negative. A number less than negative 1, like negative 2. That would be negative. So the domain of this function is what then? Negative 1 to 1, because we want this thing to be greater than 0. Negative 1 to 1 is when it's going to be greater than 0. Okay, it's a weird graph. I'll graph it on here. I'm guessing on my calculator, though, it's going to be super funky. On Desmos, it was a little bit better, but I don't want to pull it out. So log base 5. On top, it's x plus 1. And on bottom, it's 1 minus x. Yeah, there it is. It lives between -1 and 1 and makes like a little trig function in between, or a little cubic function. But that's the domain. Last one. Log of base 0.5 of absolute value of x. That's my argument. So my argument has to be greater than 0. If my argument needs to be greater than 0, talk with your neighbor. Decide what do you think your domain is going to be. What do we think? Domain. My domain is going to be all real numbers, but x can't be 0. Because if you plug in positive numbers, we're good. We plug in negative numbers, we're good because we're taking absolute value. But it can't be 0 because it needs to be greater than 0. Everybody understand how to find domain of logarithmic functions? All right, let's go to the backside. So the backside is just practicing, again, graphing logarithms. Okay, we'll do one here together to make sure we can handle it. Log base 2 of x minus 3. Okay, graphing log base 2 of x minus 3. If I wanted to graph that thing, let's start this thing off. So it's logarithmic. First thing I'm thinking about is a vertical asymptote. Where would my vertical asymptote be on a logarithmic graph normally?
0.
At 0, but it's not going to be at 0. Where is it going to be instead?
3.
At 3, because this graph is shifted to the right 3. I see logarithm. I'm thinking vertical asymptote at 0. But that minus 3 is moving me to the right 3. So that is my new vertical asymptote. You could have done the domain without graphing it. You could take this argument and say, hey, that argument needs to be greater than 0. Oh, yeah, x is greater than 3. My graph is going to live to the right of that line. Cool, it's a log base 2. So my anchor dot is going to be 1 to the right, right there. And then my next dot is going to be 2 to the right. And then my next one's going to be 4 to the right. And then 8 to the right. That is my logarithmic graph. Okay, on the first one. Range, what's my range going to be? All real numbers. Asymptote, x is equal to 3. So now let's find the inverse. To find the inverse, we're going to actually get the inverse. We could just flip some stuff, but let's write the actual equation. So to find the inverse, step 1, flipping x and y. If I want to try to get y by itself, Sarah, what do I need to get rid of first? I'm trying to get y by itself. What? Log base 2. What's the opposite of log base 2? Good. 2 to a power. You're good. 2 to a power. So over here, 2 and the log base 2 are going to cancel. Then I get 2 to the x is equal to y minus 3. Because the 2 and the log base 2 canceled. No, so then to solve it, I'm adding 3. 2 to the x plus 3 is all equal to y. Now I'm graphing an exponential. What kind of asymptote does an exponential graph have?
Horizontal.
Horizontal. Where is my horizontal asymptote going to be? 3, because this plus 3 is moving me up 3. So I'm going up to 3 right here, and I'm drawing a horizontal line. It's an exponential graph. Is my anchor dot going to be 1 above or 1 below? 1 above, so it's right there. And my next one's going to be 2 above, and then 4 above, and so on. I'm starting close to this line, not touching, and then rocket shipping out of there. Domain, all real numbers. Range, my y has to be greater than 3. Again, remember that these two things are kind of the opposites. We flip our x's and y's, so we flip our domain and range. Our asymptote line is at y equals 3. Questions on any of that? All right, I want you to try the next one. I'm going to make it easier. Just cross out that -2. Just graph the natural log of x plus 1. Graph that in the inverse. See if you can do that real quick. Go.
So is the process the exact same?
Process is the exact same thing. It doesn't matter what the base is. The base is just going to tell you the general shape. The first dot's going to be 1 away. How much is the next dot going to be away from your line when you graph natural log? E, so 2.7 away from on the next one. Talk with your neighbor, see what you can do. So we are graphing the natural log of x plus 1. It's a logarithmic graph. So just like any logarithmic graph, it is going to have a what type of asymptote? Vertical. It's normally at 0, but it's not going to be at 0. Where's it going to be now? -1, because that plus 1 is taking us to the left one. So my vertical asymptote is going to happen right here. My anchor dot is going to be 1 to the right. So it's going to go right there, right at the origin. My first dot was 1 away. How much is my next one going to be away? E. So 2.7. Then it'd be like 7 and some change.
Well, this year's homecoming won't end with a parade, a full crowd football game, and homecoming dance. It was wonderful to see students coming together to show school spirit.
As you graph the other side, it should look something like that. The inverse of natural log of x plus 1 is e to the x minus 1. Just be able to see what's happening with that.